the graphing chapter on this will be section 3.3, and we will be writing equations. And so we have been graphing equations and we've been finding slopes, and now we're going to be writing the equations for the lines that they give us some bits of information about. Now, there are three different ways that we can address a line that's a linear equation. If it's in standard form, you're going to see the x and the y terms over on the left-hand side, and just a numerical value on the right. Now, there's some special ways that this has to be written. In order for it to be in standard form, the a, the b, and the c have to be integers. That means they have to be whole numbers. They can be positive or negative, but they have to be whole numbers. But the catch is this: they want the x term to be positive when you see something written in standard form. So we're going to talk a little bit more about that later. When equations are written in this form, as we talked about on the graphing, sometimes the easiest way to graph if something's in standard form would have been to use the intercepts. We talked about that in section 3.1, and so that's one of the places that we've talked about that. And then on slope, we talked about taking something in standard form and moving the terms around so that we ended up with it being in slope-intercept form. And so slope-intercept form has solved for y. So you have y by itself, and then you're going to end up with a number next to x, and that number can be a fraction. And then you have plus or minus another number back here. Now this number by itself will always be a value located on the y-axis, and so we call it the y-intercept, and it would be written when you're asked to identify it. It always has to be written as an ordered pair. So these are all things that we've already talked about with the previous notes on 3.1 and 3.2. Now, this would be the new form that you see, and sometimes your college algebra teacher, when you get into 13-14, they're going to use this form, which is a little bit different. Now, we've seen an x1 and a y1 before, and that was because we were talking about slope. Well, the m here is still the slope, but this x1 and y1 is just going to be some point that they give you, and it's a random point. So the y value in the front and the x value in the front of the parentheses will remain variables. They'll remain letters, but then you'll plug in number values for the x1 and the y1 and the m. And when you get it in that formula, sometimes you just leave it that way. They don't ask you to change it. You would just leave it that way. So I'll show you in an example what that looks like. Now, here's the catch. You've got to be able to work between one form and another. So there'll be times when you have to change something that's in standard form to make it look like slope-intercept form. There'll be times when you get something in slope-intercept form and they want you to change it back to standard form. There'll be times when you take something that's in standard form and you have to change it to this form. So you've got to be able to interchange between the forms. Most of the time we're going to be using these two right here. So these are the two that you'll need to be most familiar with. Some of the problems we're going to work in this assignment, you can use this and that will be acceptable, and even in your homework you can use it, but you have to make sure you put your answer in the form that they ask for. Alright, now the recipe for any linear equation, you must have a slope and you must have a y-intercept. That's the minimum that you need to have. Now once you find that information, you could simply go back up to slope-intercept form. If they give you a slope number, you would put the number in for the m. If they give you a y-intercept, you would take the y value and you would stick it where the b is in slope-intercept form. So now, before we start doing and writing equations, let's look at the graph and identify those two pieces. So if I can look at a graph and identify the slope of it and the y-intercept, I'll have enough information to write that in slope-intercept form. So if I look on my graph, I can identify this one right off the bat. So my b value here is going to be 0, 4. And then from there, I'm going to find another spot where the lines cross. So let's use this dot right here, and then I'm going to count my slope. Now I know something else. This line is leaning to the left, so I know my slope value must be negative. So I'm going to go ahead and write m equals a negative number, and then I'm going to count. So if I go from here, the top point, down, I'm going to go down 3, 1, 2, 3. So my rise would be a negative 3 because I went down. But my run is going in a positive direction, so my run would be a 2. So my slope is negative 3/2. My b value is going to be the 4 that's in this ordered pair. So by taking those two pieces of information, I can write the equation. Y equals negative 3/2 x plus 4. So we've left our equation in slope-intercept form, which is really the most convenient for most of the time that you're working with graphing. Okay, so taking a line that we already know and trying to find out what its equation is. Do the same thing here. Find the y-intercept. Okay, so right here I'm going to find that y-intercept. So my b value is going to be at 0, 2. And then I'm going to count, where can I find a place where they cross? It looks like they cross like right here. This one is leaning to the right, so I know my m is going to be a positive value. It's leaning right. So this time, if I start at the lowest one and go up, I'm going to count 1, 2, 3. So it's up 3 and 1 across. So my slope value is 3. Now remember, if I go down, and so this would be negative and negative, negative over negative would still give me 3 over 1. So it gives the same value. So now when I write the 3 in the equation, I'm going to write it as a whole number, not as a fraction. And my b value will be 2, so I'm going to write y equals 3x plus 2. So this would be the equation that we would write on that line in the graphing form. Now this one has a 0, 0 is our intercept. So our b value is going to be at 0, 0. And our m is leaning to the left, so I know it's going to be negative. So then choose, just find you a spot where you got some points that are crossing. It looks like, does this work? Do those cross up there? I think so. No. Nope, it looks like, I don't want to use that one. I want to use this one all the way up here. Way up there. That's a better point. Okay, so now I'm going to count my slope. I'm going up positive, but I'm going negative to the left. It doesn't matter. One of my numbers has to be negative. So 1, 2, 3, 4, 5. So I'm going 5 and 3. So my slope would be negative 5/2. Now if I go down 1, 2, 3, that'd be negative 5 and a positive 3. So either one of these could be fine. You do 5 over negative 3. In general, you have to have a negative sign. So you can write it as y equals negative 5/3 x plus 0. Now, my intercept is at 0. So when we have a problem that doesn't have an intercept, basically you don't even have to write it. So your answer just has to say y equals negative 5/3 x. You don't have to write the plus 0. Okay? Now, what do you do when you don't have a graph to look at and count the spaces? By far, this is the easiest way to do it, but it's not easy to put a number up, put a line on a graph, and then have to figure out all the parts of it. So here's what we do. Look at the information that you're given, okay? Here it tells you you want the y-intercept to be 7 and you want the slope to be negative 2. So rather than having to figure it out on your own from the picture, it's being given to you in the information. So if my y-intercept is 7, that's going to be 0, 7 for my b value, and my m is going to be a negative 2. So now I just go back to y equals mx plus b. I go back to my slope-intercept form, and I'm going to plug in the m and the b in the spots and rewrite the equation. The x and the y stay as variables. I'm going to evaluate using the m and the b that I know. So I write y equals m is negative 2, so negative 2x. My b value would be plus 7. So then this would be your equation for a line that goes through, that has a y-intercept of 7 and slope of negative 2 over 1. So this would be your equation. This is the bare minimum. That's the easiest kind of problem to write with. Now here is a situation where they don't give you the y-intercept, but they do give you the slope. So here they're going to give you a point and a slope. Now this is a time when we can go back and use this formula right here, because it says if you have a slope and an intercept, then you use slope-intercept. If you have a point and a slope given to you, you can use point-slope. So I'm going to do it two ways for you and show you that you can do it either way, and you can choose which one works best for you. So point-slope looks like this: y minus y1 equals mx minus x1. Okay, so my x and my y with the 1's on it and the m have a number for them. So I'm going to go up here to my point. There's an x, there's a y. So I'm going to write y minus my y value that I'm plugging in is negative 1 equals m is negative 3 times x minus 4. So the formula has a minus in both places where the x's and the y's go. So you need to be careful if you have a negative number. That means minus a minus is going to turn to a plus. So I'd have y plus 1 equals negative 3x. So you're going to distribute the negative 3. Negative 3 times negative 4 would be plus 12. Now we want to get it in slope-intercept form. Okay? You have to look and see what it tells on your homework. So we're going to get it till it's in slope-intercept form. Then I'm going to move the negative 1 over and put it in with the 12. And I'd have y equals negative 3x plus 11. So there would be my equation that would fit this information. So if I plotted this information on a graph and it looked like this, I would be able to see what that line looks like. Now, if it just said do point slope formula, you would stop right here. You wouldn't go any further. You would change this to a plus 1, but you wouldn't need to go any further with that, and that would be acceptable. They most likely, on your homework, you're going to have to go all the way to here. Now, let me show you how to do it with just slope-intercept. Then you don't have to learn a whole new formula, but you might have to know that for college algebra. So here, if you're going to use slope-intercept, so we're going to do this: y equals mx plus b. All right, we've got a spot to put an x, we've got a spot to put an m, and a spot to put a y. So let's use this information that's given here. There's an x number, a y number, and an m number. Slope is an m. Okay, so for y, I'm going to stick in the negative 1. For m, I'm going to stick in negative 3. For x, I'm going to put in parentheses a 4. And then what I don't know is the y-intercept. So I just put plus b. So what I'm going to do is solve the equation to find out what b is. So then I have negative 1 equals negative 12 plus b. I'm going to add 12 to both sides. And I get 11 equals b. Now, use the m that's right here and use the b that's right here. So you're going to put these two together, and you're going to rewrite the equation and have y equals negative 3x plus 11. And there's the exact same answer done with a different formula, but you can choose. I generally think most of my students will stick with this one, and that way they don't have to learn something new. But you can choose whichever one you like to use. So they get you the same answer. Point slope will work when they give you a point and a slope, but it can also be done with slope intercept, because you'll have to find your b value and then you just go back and plug it back in. So that's one way to do a point and a slope that's given to you. Now, what if they don't give you a slope, but they give you 2 points? Okay, back from the last section when we did slope, we learned a formula for slope. So if they give me 2 points, the first thing I would do is find my slope. So the number 1 step is find your slope. then I'm going to do my y values first, so it doesn't matter which one you choose. I'll just choose the positive number, the 4. So I'm going to put 4 minus negative 8, my two y values on top, and the 4 is first, so its partner has to go on the bottom first. So 6 minus 8. Okay, then I'm going to simplify. So this would be 4 plus 8 is 12 over negative 2. So my slope number is going to be negative 6. Okay, so I have an m now. Alright, so I've got an m equals negative 6. Now, with point slope, you only had 1 point, so you had to use that one. Here, you have 2, and you can choose to use whichever one you want. Maybe you like using the one that only has positive numbers. Maybe you like using the one that's smaller. It does not matter which one, because both points are going to be on the line that you're going to have an equation for. So the second step is to take the information and plug it back in. Now you can use your point slope formula, or you can use the other formula. It doesn't matter which way. I will do this one with the slope-intercept form, because most students seem to like that. Okay, so I have an x and a y and an x and a y. I'll tell you what, I'm going to use this first one. So my y value is going to be negative 8. My m over here is going to be negative 6. My x is positive 8. And I don't know what b is, so I'm going to find b first. So step 1 is to find your slope. Then step 2 is to find your b value. So now I've got negative 8 equals negative 48 plus b. I'm going to add 48. So a negative 8 and a positive 48, b is going to equal to 40. So now the third step is to take the m and take the b and write the equation. So y equals negative 6x plus 40. Okay, that means that line would start way up on the y-axis. It would start way up on the y-axis at 40, which you probably wouldn't have a graph for. And then it's going to go down 6 and over 1, so that means it's going to lean to the left. So there's a lot of information you can tell about by looking at that line. Here we learn about some special cases. So if your equation has a y-intercept of 0, we saw that happen on the graphs just a while ago. If your equation has a y-intercept of 0, you're going to have an equation that just looks something like this. Y equals 2/3 x. There won't be a plus or minus behind it. Or something like y equals 4x. Because it would have normally been y equals 2/3 x plus 0, which adding 0 doesn't affect anything. Or it would have been y equals 4x plus 0. You just have to recognize that. If there's nothing behind the slope with the x on it, the number for nothing is 0, so there was a 0 there. Now, if the slope is 0, then that means the 0 was multiplied times x, which made it disappear, so you end up with just an intercept right there. So this would have looked like y equals 0x minus 2 to get this one, and this one would have looked like y equals 0x plus 5. So the 0 would have multiplied times the x and made it all disappear, and you just had a y and a whole number. Now, if it's a no slope, or what we call an undefined slope, okay, that meant the 0 was on the number was on the top, but the 0 was on the bottom, okay? Then that just means that you're going to have an x equals line. Okay, it just means it's going to have no y values in it. It's going to only have an x value in it. So you wouldn't have had a 0 to multiply times the y. You would have just had an x equals line. So an undefined slope gives you an x equals line. A 0 slope gives you a y equals line. Now, We talked about this earlier when we talked about slopes. So just remember, parallel means the slopes are the same. And perpendicular means the slopes are negative reciprocals. Okay? Negative, so that means opposite signs, and you flip your fraction around. Now, here's a couple of homework problems that they're going to ask you to work on. So you've got to and these are on your test, and there's one on your quiz. So you have to know how to do these. All right, find the equation of the line that's parallel to this line, and it goes through this point. Now, first, you need to put this equation into slope-intercept form so you can find the slope. Okay, so I need to take this equation and I need to move it around and get y by itself. Alright, so I'm going to move the 2x. Then I get negative y equals negative 2x plus 4. Now, I don't want negative y, so I need to divide everything by a negative 1, which just changes all your signs. So my equation is y equals 2x minus 4. So each sign has to change. Now, I'm looking for a slope. So if I want to be parallel, I need to know something about that number right there. Alright, so the slope for this line turns out to be m equals 2. Now, they want me to find the slope for a new line, but it's going to be parallel to this one. So if it's parallel, the new line will have the same slope as this old line. So the new equation that I'm going to work on is going to also have a 2. So m will also equal 2 because they have to be the same. Now, use that parallel slope, that's the m equals 2, and use the point that's given, and then you can use point slope or slope intercept to get the equation. So the first thing you have to determine is what is the slope of the line that they give you. So you change that around. So the first thing here we have to do is find the slope. So I'm going to move the equation. So there's my slope. Okay? Now the next thing to do is use that slope, use m equals 2 and the point 2, negative 3, and write your equation. So you can use either one. Okay, this time I'm going to use point slope. So let's do this one. Y minus y1 equals m times x minus x1. We'll just leave this one in point slope form this time. So I'm going to say y minus y1. So my y value is y minus negative 3 equals m, which is 2 times x minus 2. And all I'm going to do on this one is just simplify and call it y plus 3 equals 2 times x minus 2. And I'm going to leave it that way. So you can leave it in point slope form, and that's an acceptable answer. Now, if you had to change it and get it in slope intercept form from there, all you're going to do is distribute the 2 and then move the 3 over so it ends up, and you'll end up with a different form of it, but we're going to leave that one for right now. Now, number 5 example here says I want the line that's going to be perpendicular to 3x plus y equals 1. And it has an x-intercept of 2. Well, let's think about that. If the x-intercept is 2, then it's a point that looks like this. Okay, a y-intercept would be the b value, but this isn't a y-intercept, this is an x-intercept. So this is going to be my point, but I'm going to have to figure out what slope I'm going to need. So I'm going to take this equation and I'm going to solve it and get y by itself. So I'm just going to move that 3x over. So I get y equals negative 3x plus 1. So there's my slope. Okay, there's your slope. That's what you're looking for. Now, if I want perpendicular slope, that has to be the opposite reciprocal. So this would be negative 3 over 1. So I need to flip it and change the sign. Okay, so perpendicular is an upside down T. Okay, perpendicular M is going to be 1/3. That's an M. So perpendicular slope. So this is the slope I need. Alright, perpendicular slope is 1/3. And the x-intercept, that ordered pair, is going to be 2, 0. Okay, now I've got a slope and a point. So let's do point slope. Okay? Plug in the information into point slope form. And here's our form right here. Okay, here's our form. So we're going to go back up and we're going to use the y, the m, and the x that I have right here. So I have a slope that's going to be 1/3 and I have a point that's 2, 0. So I'm going to go y minus 0 equals 1/3 times x minus 2. Well, that's easy. Y minus 0 is still y. So I have y equals 1/3 x minus 2. Now, this is point slope formula. This is point slope answer. Okay, if I'm going to get slope intercept, I'm going to distribute that 1/3. So y minus equals 1/3 x. 1/3 times 2. Well, that's 2 over 1. You just multiply straight across. So 1/3 times 2 would just be minus 2/3. So this would be your slope intercept form. So it depends on what answer you're looking for. And slope intercept, you multiply it out. So this would be one answer and this would be the other. So it depends on what answer you're looking for. Now, when standard form is required, okay, the definition for standard form means you want x and y on the same side, and you want no fractions, and you want your x term to be positive. So that means we've got to kind of move some things around to make it fit this form right here. Now, sometimes you've got to look because they're going to give you the answer in a different form. So if you write your problem and you get it in this form, but the answer is in standard form, you're going to have to do some moving around to try and figure it out. Okay, so the first thing I would do is I want to get the x and y on the same side. So that means this x term has to move back over here. Whenever it crosses the equal sign, the signs are going to change. So I'm going to add 2x, add 2x. So now I end up with 2x plus y equals 3. And then you have to ask yourself, is x positive? Yes. Are there any fractions? No. So that's your answer. That's what you want it to look like. Right? So here, I need the x to move over, so it's going to become positive 1/4 x. So I'll have 1/4 x plus y equals 5. Well, that's a problem. It's positive, but it's got a fraction. So we go back to what we did with solving equations, and we use a common denominator. So when we multiply the common denominator, it will cancel off the 4. So I'm going to multiply this, everything, by 4. So the 4's will cancel on the first one. So you're going to multiply it times every piece of the problem. So this one will cancel and you'll just have x, 1x or x. Then 4 times y would be 4y. And 4 times 5 would be 20. So this is now in standard form. Okay? The third one, if I move the 2/3 over, the 2/3 is going to become negative. So if I move it over to the left, I'll get negative 2/3 x plus y equals negative 7. Well, now I have two problems. I have a negative on the front and I have a fraction on the front. Well, we can kill two birds right here by doing the sign would have to have a -3 because a negative would just change your signs, but the 3 would cancel off the denominator. So by using a negative on the denominator that I need, it'll change all my signs and it'll also clear out the fractions. So your signs are going to switch. The 3 on the fraction is going to cancel. So negative times negative will become positive 2x. Then I multiply negative 3 times y, and I get negative 3y. And negative 3 times negative 7 would be plus 21. Now I have no fractions, and I have x being a positive term, and this is standard form. Now on the last one, remember there's no y-intercept here. So this time it would be helpful to remember that there's a plus 0 there. Now when I move my 4x over, it becomes negative 4x plus y equals 0. Then you've got a number there, so this would be one where you want to write the plus 0 in. But I don't want a negative on the 4, so I'm going to multiply everything by negative 1, and that just changes your signs. So this then would become 4x minus y, and you keep that 0, so it still equals 0, and there's your standard form. So this will be a concept that we have to do occasionally just because they ask for it to be done. So I hope this helps, and